Hello dear students. Here we have a question that says 6 charges are placed around a regular hexagon of side length A as shown in the diagram. So we have a diagram where we have this regular hexagon and 6 charges 1, 2, 3, 4, 5 and 6. They are placed around the hexagon. Now 5 of these charges, they have the magnitude Q. You can see that in the diagram. And the remaining one has the charge x. This remaining one, the sixth one, it is having the charge x not equal to q. Maybe or may not be, it can be having some other value. The perpendicular from each charge to the nearest hexagon side passes through the center O. So this perpendicular drawn from any charge to the nearest side of the hexagon would pass through the origin O. And it is bisected by the side. Bisected by the sides, that means if length here is L, this would also be equal to L. So the total length of any charge from the center O would be equal to 2L, where L from the geometry you can see that L would be equal to root 3A by 2, where A is the side length of the hexagon. Or I can say that the value of 2L, where L is equal to root 3A by 2, the value of 2L would become equal to root 3A. So from here till now, we know that every charge, whatever its value is, every charge is placed at a distance of root 3A from the center O. Now, from the following statements, we are supposed to find out the correct statements again. The option 1, it says that when x is equal to q, magnitude of electric field at O is 0. So, if x is equal to q, all the 6 charges placed symmetrically having the value q, definitely they would be cancelling out each other's electric field components at point O, and the net electric field at point O is going to equal to 0. That would make the option 1 a correct option. Option 2 talks about that when x is equal to minus q, the magnitude of the electric field at O is q upon 6 pi epsilon naught a square. So let us just check this claim now. So if x is equal to minus q, let me just name the charges first of all, and the charges can be named as A, B, C, D, E and F. These are just name of the charges. The charge A and D, they would be cancelling out each other's electric field, while the charge E and B, they would be cancelling out each other's electric field. Fine. So only components that would be there on the center O, they would be due to the charge F and the charge C. Now due to charge F, the electric field at point O, it would be K Q upon root 3A whole square in the downward direction. Because of the charge C at point O, the electric field would be K Q upon root 3A whole square, again in the downward direction. So both of them, they are going to be added up. So I can say that the net electric field would be 2K, which is 1 upon 4 pi epsilon naught, into Q upon 3A square. Now if you calculate this value, this would be coming out equal to Q upon 6 pi epsilon naught A square, which is as given in option 2. So that would make the option 2 also a correct option, as it was only talking about the magnitude and the direction would be in the downward direction. Option 3 talks about when x is equal to 2q, the potential at O when x is equal to 2q. Now if you see, with the value of x equal to 2q, all the charges, they would be at the same distance, that is root 3a from the center. So the net electric potential, it is a scalar quantity, so the net electric potential at the center O would be the net charge, which I can say Q total, into K upon root 3a. That would give me the value of net electric potential at the center. The Q total, that is the net charge of this whole configuration, it is nothing but 7Q. For option 3 I'm talking about. So 7Q into 1 upon 4 pi epsilon naught, which is the value of K, into 1 upon root 3a, that is 7q upon 4 root 3 pi epsilon naught a. 7q upon 4 root 3 pi epsilon naught a. That would give me the value of the electric potential at point O. So that would make the option 3 a correct option. Option 4 talks about when x is equal to minus 3q, the potential at O is this value with some negative sign. Now if you see, even if x is equal to minus 3q, the q total, this q total, it is going to remain positive, that is equal to 2q. That means the electric potential, the value of electric potential is going to come out equal to positive. So this negative value itself, it is making this option a incorrect one. So the option 4 would become an incorrect choice. So for this question, option 1, 2 and 3 would make the correct combination of the choices. Thank you.